Okay, welcome to this video on the sine rule at National 5 level. What is the sine rule? Well, the sine rule is a formula that we can use to find the length of any side of a triangle or an angle, given that we've got enough information. I'm going to derive the sine rule for you. It sort of dovetails with the previous video on finding the area of any triangle at National 5. So first thing we always do with a triangle at National 5 is we label it and we look at the angles and we find the lengths. So the angle at A, opposite that is the small a. The angle at B, opposite that is the small b. And the angle at C, opposite that is small c. Next thing we can do is I'm going to put in the vertical height of the triangle that we've got here. Remember, this is the height that makes a right angle with the other side there. So we get two triangles and they're both right angles here. And that's called the vertical height, which I'm going to call it H. Now, looking at this here, we can come up with a value using SOHCAHTOA for H. And here's how we do it. Okay, so sine A, so sine of this angle here, using your SOHCAHTOA from National 4, is the opposite, which is H, over the hypotenuse, which is C. So that's H over C. Now we can do it for this side as well. So this triangle here, so sine C is equal to the opposite, which is H again, over hypotenuse, which is A. Now, if I rearrange this into H equals, I get C sine A, and I get H for this one is equal to A sine C. Now, these two things are the same. So it's true to say then that C sine A is equal to A sine C. Okay, and if we just rearrange that, then it tells us that sine A over small a is equal to sine C over small c. And I won't do it for B, but it is true to say that sine B over small b. So these things are all the same, and this is called the sine rule. Okay, sine rule. Now, using your equation rules, we could flip each one of these, and we could have A over sine A is equal to B, just put them in order now, sine B, and C is equal to over sine C. They're the same. Okay, what one do you use? Well, in the exam, National 5 exam, this is the version they give you. They don't give you that version, but you can just flip them when it suits. What do we use? Well, it just depends on the question. Okay, it doesn't matter which one you use, you come up with the same answer. So I'm going to show you the first one that I want to do, and it's to find our length. Okay, so we're just going to call this A, B and C again, make it nice and easy. And I'll put in 10 metres I think for this one. And we'll give two angles, 41 degrees and 34 degrees. Okay, and my question is, what's the size of that length there? Well, let's just define it. Find the length of BC. Okay, so that's my question. Well, first thing we'll always do with these is we label the triangle properly. So there's angle A, there's that big angle there, so that's small a. Angle at B is up here, probably don't need this one. Other side is small b. And angle at C, other one, small c here. We could find B here. Angles in a triangle add up 180, so we could find this one here if we want. But my question is to find essentially A. So, first thing we do is we write down sine rule. A over sine big A is equal to B over sine big B, and C is over sine big C. Now what we try to find, so I like to put a question mark here. This is what I'm trying to find, a wee question mark. So it's this value up here. Do we know sine A? Well, we can work out sine A, so give a tick. Do we know, what else do we know? Oh, we know C, the line of C, tick that. And we know the angle at C, we tick that. So we can cross out that, we don't need that. Okay, we could calculate these things if it was going to be useful to us, but we don't need it. So here we go here. I'm going to be using A over sine big A is equal to C over sine C. Now to use the sine rule you need to know 3 out of 4, right? 1, 2, 3, 4. That's always the case for the sine rule. You have to know 3 out of 4 so you can find the missing part. So that's when you can use the sine rule. So rearranging that, well, I'm just going to arrange that before I put the numbers in. So let's rearrange it. A then, that's what we're trying to find, is equal to, I'm multiplying through by sine A, so that's going to be C sine A over sine C. Plug in my numbers. Well, what's my C? My C is 10, and my sine A, when angle A is 41 degrees, all over sine of the angle at C, which is 34. And all I have to do now is I plug in my numbers, and whatever that comes to, that's my answer. So I'm using my calculator here, and I'm going to come up with my value, and it comes to approximately 11.74 meters. So that side up here is 11.74 meters. And that's what you do. Now that type of question is a very basic question, therefore it will be worth about, roughly speaking, I say 3 marks probably, around about 3 marks, okay? So the next one I'm going to do with you is to find an angle. So let's try and find an angle for one of these. So I'm just going to rub this out and set up another triangle. This time I'll just do it roughly, save a wee bit of time. Something like that. Something like that. Yeah, like that. Let's put some values in. Let's call ABC again, just to save any confusion. B, C, and I'm going to put 45 meters here. And I'll put in 38 meters here. And we know this angle here, I'll just make it 23. And my question is find angle A. Okay, so let's find angle A. We'll call it angle BAC, which is that angle at A here. Okay, so as we always do, label the triangle. So this is small a over here. Opposite C is small c, and opposite B is small b. Now I'm finding an angle this time, so I'm going to flip this formula and use the first one here. I think it should make it a wee bit easier for me. So sine A over small a, sine b over small b, and sine c over small c. So what we try to find, we're trying to find the angle A, so put a question mark there, sine A, that's what we're trying to find, we're trying to find A, so we have to do shift sine at some point. We know A, so tick that. Again, we know the angle at C, so tick that, and we know the length C. So again, we're rolling out B. So rearranging this, we're going to have sine A over small a is equal to sine C over small c. And let's put in the numbers. Well, let's rearrange it and then we'll put in the numbers. Sine A is equal to small a sine big C over c. So sine A is equal to, so what do we have? A is 45, sine C, angle at C is 23, and the length of small c is 38. So we work that out. Now it's just a wee bit more involved. So putting it in our calculator, this should give us sine A is equal to 0.463, and A then, I'll put it over here, A is equal to shift sine in the calculator, and putting that in the calculator should give you an answer of approximately 27.6 degrees. Okay, so I've showed you how to find the length of one of them, I've showed you how to find an angle. Now again, a very basic question. Questions in National 5 are usually a bit harder, and I'm going to do a question that's a bit harder, a past paper question, where it involves SOHCAHTOA as well as the Sine Rule. Okay, so it's normally worth about a 5 marker in the exam, so a wee bit more involved, and that's what tends to happen in the exams. Okay, you tend to get questions that are a good bit harder than the basic, so you have to think a few times. That's why National 5's a good bit harder than National 4. So I'm just looking just now for a question that I think is quite suitable for you. Let's see if we can find one. Yeah, quite a, this one I'm going to show you. I'm not going to write down all the stuff in the question. Just going to show you the diagram and how we go about doing it. Okay, so it's all to do with a satellite, and it's labelled TSV, and S for the satellite up in the sky, and it tells you that this is a transmitter and this is another transmitter, and it's 500 kilometres between these two. Okay, so we've got 500 kilometres between these two places, and we're told that the angle here is 35 degrees, and the angle to the satellite from the other side over here is 40 degrees. Now the question says, how high is the satellite? Right, so how high is the satellite above the ground? So the height of the satellite is going to be here. Now if you've watched a video on the area of a triangle, any triangle, then we're combining bits of these two videos, this video here and the last video, to work out this question. So how do we go about this? So we have to find this, we're going to call H, right, the height H. Well, a few things we could do. First thing we always do is we always label, right? Always label the triangle. So this is small t. This side here is small v, and the bottom side is small s. Well, let's see. First thing I'm going to do, I think, is find this angle here. Okay, this big angle here. Well, it's got to be 180 minus 40 and minus another 35. So I'm going to do this wee calculation here. So I've got 75, so that's 40 and 35 is 75 degrees. And take that away from 180. That's going to give me 105. So this angle in here is 105. So I'm just going to put that in there, 105 degrees. Hopefully you can see that, 105 degrees. And if I find either V or T, doesn't matter which one I find, then using a bit of SOHCAHTOA, because we've got right angle triangles here, we can work out the height of the satellite. So let's write down the sine rule. Sine rule, and I'm going to write T over sine big T is equal to S, small s, over sine big S, and that's what we've just calculated there, so that'll be a mark in your exam, is equal to V over sine big V. So, what are we trying to find? Well, I want to find V or T, because if I find V here, then I can use a bit of SOHCAHTOA to work out the height, or I can use this, I can find small t and work that out. Doesn't matter what I use, but let's see. We know small s, so tick that. We know the angle at s, so we're definitely using that. And I don't know, I think I'm going to find small t. I'll just roll this one out. Okay. So we've got small t is equal to, well, multiplying through by sine big T will give me small s sine big T over sine of big S. Plugging in my numbers, we get 500, that's small s, sine of T, well, there's angle at T here, it's 35, all over sine of big S, which is 105, and that's what we had to calculate it right at the beginning. So that's going to give me T then is equal to, now I just need to put that in my calculator, see what it comes up with. So here we go, 500 times sine of 35 divided by sine of 105, and that comes to 296.9. I'm just going to call it 297. Or will I? No, I'll just leave it. 296.9. And that's kilometres. We put it to one decimal place because we want to be reasonably accurate with this. So we now know, I'm going to put this in here, is T is 296.9 kilometres. But it's the height of the satellite. Now, this sloping line here is not the height of the satellite. That's the distance between this point here up to the satellite. But we want the altitude line, the height, the actual height from the ground. So I'm going to draw a wee triangle here, and it's a right angle triangle. And we've got 40 here. This is V. This is my H. S is my satellite, and I know this is 296.9 kilometres. Now this is a right angle triangle, so I'm using this wee bit, I'm running out of space here, but using the SOHCAHTOA here, then sine of that angle, sine of V, is equal to the height over the hypotenuse, which is 296.9. So h then is equal to 296.9 sine, well, big V, the angle there is 40 degrees. And if we bump that into our calculator, run out of space, that will be the height of the satellite. So let's work that out, 296.9 times sine of 40. Approximately 190.8, and that's kilometres. So that satellite is 190.8 kilometres high. Okay, and that's a past paper question, and that's easily worth 5 marks. So where does your marks come in? Well, mark for that definitely 105, because you had to work that out. And then known to use the sine rule, I don't imagine there's another mark, that's 2 marks. Putting in your numbers, etc., probably down to here is 3 marks, and working out these 4 marks. Now, SOHCAHTOA is really a national force skill, so you probably get 1 mark for the end of here and up to your answer here. So I would say around about 5 marks. Okay, so that's the sine rule. So I've covered finding an angle, a basic angle, finding a basic length, and I've showed you a more complicated one where it's a sine rule and a bit of SOHCAHTOA for the National 5 questions. Now, make sure you can get to this level here. Practically every question at National 5 is, for SOHCAHTOA, is round about this type of idea, finding heights of a block of flats or something, or a satellite, or that type of idea. So they're quite involved. They're a 5 marker every year, and you can do this. And the next video is going to be a cosine rule, which is going to be along the same idea, different formula, but the same sort of techniques that we've got here. And that always comes up every year as well. You're talking about between the area of any triangle, sine rule and cosine, you're talking a good 13, 14 marks normally in the exam. So it's something you can't shy away from. You have to make sure you can do it. Okay, so my next video is a cosine rule.